This is section 8.1 in MathLinks 9 on algebraic equations. The first question we have here says to solve the equation half of y. And remember, I'm going to read it. You could say y over 2. That's not what it says. That's just what it looks like. Or you could say y divided by 2. Or most importantly, you could say half of y. So when I read that, I want to be able to read it properly. I want to say half of y is equal to 5/3. John first multiplied both sides by 3. Oh, John. Oh, John. Why would you do such a silly thing? Do you think that John's first step is the best way to isolate the variable y? Explain. And the answer obviously is no, because I groaned. Now, multiplying both sides by 3, here's the interesting thing. Will that make it an inequality? Will that change its equality? Will it still be equal after doing so? It will work. So let's just do it anyway. See what happens. See what John figured out. So I'm going to multiply this side by 3 and multiply this side by 3. I end up with 5. So when you multiply 5/3 by 3, you get 5. And when you multiply the other side by 3, you get 3y divided by 2. Now, the reason why this is not the best way to isolate the variable is because what John is doing, he's making an easier question into a more difficult one. He's adding steps that don't need to happen. Now, what would you do if you were John and you're like, oh God, why did I do that? What would you do next? Instead of erasing the work you did, what would John's next step be? Anybody, just don't be shy now. It's Friday morning. Avery, you seem like you're waking up. What would you do next? Well, that's excellent. So the next thing I would do is I'd be like, okay, here's equality. We're still equal. If I double both sides, let's see what happens here. If I multiply this side by 2 and I multiply this side by 2, well, the neat thing is multiplying this by 2, I end up with 3y equals 10. I'm like, oh, great gravy. I'm getting closer to the end. And now what would you do? You would divide both sides by 3, and you would get the answer of y equals 3 1/3. Because 10 divided by 3 is 3 1/3. However, if John wasn't such a banana head, John would have realized that multiplying both sides by 3 was not a great idea. John could have made his life incredibly easy if he simply multiplied both sides by 2. By multiplying this side by 2, you've already isolated the variable y, and you end up with 10 over 3, which is equal to 3 1/3. You did it in one step instead of 2 steps. Instead of 3 steps, actually. So the idea, what you need to remember is, in algebra, your goal is always to isolate the variable. So you always want to get rid of the things on the side of the variable that don't belong there. In this case, the divided by 2. You do not wish to tamper with the side that does not contain the variable, even though sometimes it's okay to do so. But you don't need to. That was a long 3-minute explanation for one question. Question 2 says, when Ming solved 0.3g or 3/10 of g, ooh, that's a good way to read it, is equal to 0.8. Her value for g was 2.6 repeating. She expressed this to the nearest tenth, or 2.7. When Ming checked by substitution, she found that the left side and the right side did not exactly agree. How could Ming make the left side and right side agree more closely? Who has an answer for this one? How could Ming, who solved it to get that, how could she make it easier? Instead of rounding to decimals, does anyone have an idea? Let me just show you again. So she did 0.3g equals 0.8. So she divided both sides by 0.3. And she got g equals, and then she took her calculator and she goes, well, it's 0.8 divided by 0.3. And she got 2.6 repeating, which she said is approximately equal to 2.7. And then she said, well, hold on, let's just take this equation again, 0.3g equals 0.8. Let's put in my 2.7 answer, so 0.3 multiplied by, instead of g, I'm going to put that 2.7 in, and then she took her calculator and said 0.3 times 2.7, and she got 0.81. And since 0.81 does not equal 0.8, she's like, oh God, that's not exact. What could she have done? The answer, if she could have used fractions. Let's take a look at this if we use fractions instead. So 0.3g equals 0.8. Let's change these instead of decimals. Let's make this into a fractional coefficient. What's 0.3 as a fraction? Anyone want to just read the decimal? Go ahead and read the decimal. What decimal is that? 3/10. So we're going to make it into 3/10 g equals 8/10. Here's the benefit of using fractional coefficients as opposed to decimal coefficients. Now what do you do here? You're going to divide both sides by 3/10. Agreed? That's going to go. Everyone are with me so far? I'm going to divide by 3/10, which is going to be keep the first fraction, change to multiplication by the reciprocal. And when you work this out, if you cross reduce, it's much easier because you get 8/3. But I won't cross reduce. I'll go 80/30ths, which is equal to 8/3, which is equal to 2 2/3. Is that the exact answer or is that the approximate answer? Is 2 2/3 the approximate answer or the exact answer? It's the exact answer. So what we avoid here is when you use fractions for repeating decimals, you will always still get the exact answer as opposed to something like this, where rounding doesn't actually give you the best answer. The length of Shamika's stride is 0.75 meters, or 3/4 of a meter if you want to think of it that way. Just to make sure you're thinking this way, 3/4 of a meter, same thing. Both Amalia and Gustav were trying to calculate how many strides it would take Shamika to walk 30 meters from her home to the bus stop. Amalia represented the situation with 0.75p equals 30. By the way, what does p stand for? The p stands for pace. So 3/4 of a pace, right, equals 30. So if we take this, if she took 3 steps, or instead of saying 3 steps, 3 paces, how far would she have gone? How would I get how far she went? I would take the number of paces. I would take the number of paces and multiply it by 0.75, which means 0.75 meters, or 3/4 of a meter, multiplied by the 3 paces she took. She would have traveled 2.25 meters. That's just if she took 3 paces. You with me? So by saying I don't know how many paces she took, but I know each of them 0.75 meters, if I multiply the number of paces by 0.75, that has to equal the distance she needs to travel, which is 30. This is a perfect formula. Gustav, on the other hand, said, if you take the 30 meters that she has to walk, and you divide it by the number of paces, then that number of paces has to equal 0.75. So let's, for example, if she took 1 pace, would 30 divided by 1 equal 0.75? No. What if she divided it by 10 paces? Does each of those paces, if she took 10 paces, how long would each of those paces have been? If she took 10 paces for 30 meters, it'd be 3 meters a pace. So if I use this formula also calculates how many paces that Shamika needs to take in order to go. So both are good. Which one would you prefer using? My preferred one is A, but I like B as well because it shows some little bit of outside the box thinking.